Okay, welcome back to our video lesson for the CNT 140 LAN wiring. Today we're going to be covering Chapter 6, the work area outlets. Now, our objective in this chapter will be highlighting outlet jack mountings, the modular jacks for twisted pair, standard jack pinouts, fiber optic jacks, marking the outlets, and of course workmanship. So we begin to go through the chain of wiring devices that make up a LAN wiring connection. The first item in our list is the outlet placed at the workstation area. Now the 560AC standard requires that each work area be provided with two outlet jacks. One jack must be a 4-pair 100 ohm UTP or STP connection of Cat5e or better. Now the 568B required Cat3 or better. Now the other jack may be a category 5E or higher 4-pair 100 ohm of UTP or STP connection, or it can be either a 2-fiber 5125 UM or a 2-fiber 62.5 125 UM fiber optic connection. The work area outlet is referred to by several names. 568C standard refers to the outlet as telecommunications outlet connector in the work area to emphasize that it must include the actual connector jack itself. We refer to the outlet in this book, in this lesson, by the name work area outlet or station outlet. I, in the past, have always called it a telecommunications outlet. This usage implies that the connector jack is not directly attached to the workstation or another network device, such as an attachment is made by an additional cable called a user cord or an equipment cord. The modular or other jack typically attaches to a mounting plate or a faceplate, which mounts in an enclosure. The entire assembly, the jack, plate, and enclosure forms the station outlet. Now we'll cover the mountings and the jack types first. And we will also discuss mounting methods for the jack faceplate assemblies, including service and flush mountings. And finally, we will detail outlet identification and any workmanship issues. So let's start off by talking about the outlet jack mountings. The connector jack at the work area outlet is mounted in several ways. We will cover the mounting first because it's useful to have an understanding of connector mounting methods when we actually begin to discuss the jack types in the next section. In this discussion of jack mountings, we're actually talking about the faceplate jack assembly in those instances where a separate faceplate would be used. So we'll start off with flush mounts. Flush mounted jacks are the familiar wall mounted jacks that we often associate with commercial telecommunications wiring. Type of jack arrangement places the jack faceplate flush or even with the wall. Typically, the jack extends into the wall and mounts via machine screws to an underlying outlet box or mounting ring. Mounting rings and outlet boxes are discussed here. The mounting ring or outlet box provides a secure location for mounting the work area outlet. Several types of each are available. Generally, either type of mounting is acceptable. Telecommunications wiring is a low voltage, low amperage wiring that is not required to be routed in conduit or mounted in an enclosure by the NEC. However, your local construction codes may require that the outlet be mounted in an enclosed box in some cases. Traditional outlet boxes are the same design as those used for electrical conduit wiring, electrical circuit wiring. The boxes are available in metallic or plastic styles, and different designs are available for pre-wiring during the initial construction and for post-wiring when the building is complete. The figure behind me shows several types of outlet boxes that are suitable for telecommunications use. The 2-inch wide box is the most common for this style of wiring, although a 4-inch square box with a 2-inch wide mounting ring may also be used. In general, the telecommunications outlet plates that mount to these boxes are designed for the 2-inch opening. The opening sizes are also referred to as 1 gang or 2 gang or 2 wide boxes. And that's how we look at them in the trades. Outlet boxes for pre-wire use will have nail plates for attachment to vertical supports or studs in the walls. Some of these boxes have nails that are already attached to the box. You just wind up and swing. The box should be securely attached to its support and positioned to allow for clearance through the wall sheathing. You will notice that on most boxes on the side of the, especially on the plastic ones, there will be little notches based on whether or not it's going to be 1/2 inch, 5/8, or 3/4 inch drywall. You just line up accordingly that way. After the wall is complete, the mounting plates of the box should be even with the wall surface. The box should be positioned at the same height as required for the electrical outlets. This might not necessarily be a construction code requirement, but it does enhance the appearance of the final installation. The cable may be run through a bare knockout hole in the box or through a conduit or a flexible cable connector. Plastic sleeves are also available to minimize any chance that the cable might be damaged by the hole's sharp edges. Outlet boxes for post-wiring use are also available. Now, these boxes are sometimes called old work or sheetrock boxes because they mount in hollow walls that have already been constructed. They must be inserted in the front of the wall, and an opening that is cut into the wall big enough to insert the box body. Additional room may be required for the mounting device that secures the box to the wallboard. These mounting devices are usually screw tightened to clamp the mounting flange to the box to the wall. Another type of flush mounting device is the mounting ring. And mounting rings are available in several varieties, as shown here behind me, and standard mounting rings provide a target location for telecommunications outlet during construction. These rings have mounting plates that allow them to be attached to the wall's vertical supports. Now, the mounting ring normally has a 2-inch by 4-inch opening that is formed into a flange. The flange then protrudes from the wall support and is the right depth to be flush with the front of the wall surface when it is later attached. The top and bottom edges of the ring have mounting holes to which the mounting screws of the outlet do attach. Now, mounting rings for post wiring are also available, and these rings have flexible metal fingers at the top and bottom of the opening that are part of the stamping. Now, a rectangular hole of an appropriate size is cut into the wallboard. Then the mounting ring is placed into the hole until it is flush with the wall. The metal fingers are bent around the hole and then back against the rear surface of the wall to secure the ring. An alternative design has a vertical screw slot incorporated into the metal fingers. After the fingers are bent into the mounting hole, a provided screw clamps the front flange of the ring tightly into the wall using the slotted finger as a rear clamp. This prevents any undesired movement in the ring that would occur with the other type of rings. We have pre-wire and post-wire methods. Pre-wiring may be accomplished with actual cable runs or with a combination of pull strings and late-stage cable runs. If the actual cable is used for the pre-wire, it must be installed at the stage between the wall support installation and wall sheathing attachments, and this is often referred to as the rough-in stage. With the wall supports in place, the cable is run from each wiring closet to each serve station outlet or ring, and either coiled inside the box or secured to the ring. After the wall sheathing is in place, and usually after the wall has been finished or prepared, each cable is then trimmed to working length and terminated in the jack. The assembled outlet is then mounted in the box or ring. Using the actual cable in the rough-in stage can present some problems if you're planning a full Cat 5e or 6+ installation. The cable is left exposed and subject to damage by others during the construction. In addition, you must coil up the wire very carefully to avoid the sharp bends and kinks that can disturb cable performance at the category of operation. Another technique is to leave a pull string in the wall during the rough-in. Place in a hollow wall or inside a riser that connects to the outlet box. The outlet boxes have vertical risers or conduit that run from the top of the box to the wall's top plate and a 1/2 foot or so into the plenum space above the ceiling grid. Pull string can be run through a conduit to assist in cable installation. If a mounting ring is used for the outlet, a pull string is particularly convenient. The opposite end of the string should be secured to anything above the top plate where it will be visible to the cable installer. After the wall construction is finished, and preferably before the ceiling tiles are in place, the cables are run from the wiring closet to each outlet's pull string, attached and then pulled into the outlet, where they may be terminated. Pull strings and conduit are effective ways to run cable into difficult outlet locations, such as below windows or in columns. The cable may be coiled and secured above a planned outlet location for later pulling into an outlet box or a ring. Again, if you're planning on a Cat 5e or 6 installation, be careful not to put sharp bends or kinks into the cable. Tie wrap may be used sparingly, but should not be overly tightened. You should take care when running your cable into an outlet box so that you don't slice through the cable jacket. Metallic boxes often have sharp edges as a result of the way they are manufactured, and these sharp edges can cut into the cable and short some of the wires. Mounting rings may present other hazards to cable, such as sharp screws that are used to secure some of the rings to the wall sheathing. Now let's talk about surface mounts. So what do you do when you can't mount the outlet jack inside a hollow wall? Well, you can use an outlet box that is specifically designed for mounting on the surface of a wall. Now these mountings are called surface mount boxes and come in two varieties, self-contained and surface adapter boxes. The self-contained surface mount outlet contains one or more connector jacks for the type of telecommunications or LAN service that you're installing. These boxes are often called biscuit blocks because of their appearance. A typical surface box, shown here behind me, contains two modular jacks. One may be used for data and then one for phone. The 560AC standard calls for 2 circuit links to each workstation, but leaves the use of the links up to the user. Both should be fully wired. 8-position RJ-style modular jacks or appropriate fiber jacks to satisfy the standard. Although you may wish to make one 6-position RJ11 style jack if your telephone system calls for that. This is particularly appropriate if you choose to totally separate the telephone and data wiring, as we discussed earlier. Self-contained outlet boxes are appropriate for solid walls, modular furniture, and other difficult to reach areas. Care should be taken to protect the wire with a surface raceway if it is exposed. Providing strain relief to the cable is a significant problem with these boxes. Standard practice is to tightly secure the cable at the point of entry of the box with a tie wrap or a knot in the cable. This would obviously distort the cable jacket or break the minimum bend radius of the cable allowed by the standard for Cat 5e and 6. If a box can be secured to a surface, or a better approach might be to then use a surface raceway to protect the cable up to the point of entry to the box and then leave the cable entry relatively loose. These surface raceways are described next. The other variety of surface mount box shown here behind me is a rectangular plastic box with a 2-inch by 4-inch opening for a standard flush mount outlet plate. These surface adapter boxes are really part of an elaborate surface raceway system that is technically suitable for electrical wiring, in addition to telecommunications wiring. The system includes a long, flat plastic raceways that may be joined together with a variety of couplings, including corners and straight couplers. Surface raceways are available from several manufacturers. In older systems of metal raceways and boxes exist, but the plastic ones are much easier to use and are permitted in almost all jurisdictions for Class 2 or 3 wire or telecommunications wiring. Many of the plastic raceways have an adhesive foam tape backing for quick and easy mounting to the wall or other surface along which they run. Please be careful when using these self-adhesive raceways because once they're stuck on, they are there to stay. And if you don't have them on perfectly straight, you're going to be staring at that crooked raceway for now until eternity. The boxes may also come from foam mountings, but you are better advised to secure them to the wall with screws. The screws also help stabilize the entire raceway system. Other plastic raceways are available that do not interlock with the surface box. These raceways are the same type of foam tape mounting but snap closed after installation so that the wires can be slipped in at the side of the raceway after it has been stuck to the wall. These raceways are more appropriate for these self-contained surface outlets. A note of caution should be stated regarding these raceways and matching boxes. The safety standards of the NEC and other agencies do not allow telecommunications wiring to share any Raceway space or outlet box with Class 1 wiring. Class 1 wiring is wiring for lighting or electrical power circuits, the typical line power that supplies lights and electrical outlets. In some narrow cases, the wiring may be allowed in the same outer Raceway cover, but it must be separated by a specific type of partition. You can see the code books for a detailed explanation of when and where this can be done. Now bear in mind that the run-of-the-mill square power pole that drops from the suspended ceiling to a work area rarely meets this test. Even though there's plenty of extra room inside the telecommunications cable, some modular furniture may have the same problem, as the wiring channel may be occupied by Class 1 wiring. In such cases, you may have to run telecommunications wiring external to the wiring channel. There are several varieties of multimedia copper and fiber outlet boxes that are shown here behind me. So, modular jacks for twisted pair wiring have been around since modular connectors were first introduced several decades ago. And the first of these jacks had loose wires from the connector to screw terminals mounted to the body of the connector assembly. Now, because these jacks were for analog telephone use at very low frequency, little consideration was given to the crosstalk and impedance issues that are very important at today's higher frequencies. Jacks for LAN use are very different from these old telephone styles. And in this next section, we're going to talk about the various types of jacks that are used for twisted pair LAN wiring. For our purposes here, the jack will include the modular connector itself, the means of terminating a twisted pair cable, and the wiring in between. So let's look at jack plates. There are three basic types of mounting plates for modular jacks: fixed plates, modular plates, and modular assemblies. So don't be confused by the word modular. Here, as we're referring to the fact that some of these devices snap together with different options. Fixed jack plates are the traditional type of plate. These plates are made of molded plastic and include the opening for the modular connector as well as a mounting for the connector and termination components. The most common fixed jack plates have one or two connector positions and are often referred to as simplex or duplex jacks. The plate opening and its related molded structures form an integral part of the connector assembly. The connector cannot be separated from the plate and used alone. This is the reason the jack plate is called fixed. The supports for the connector terminations are also usually molded into the plate. The most common type of termination is a screw and washers that attach to the molded post of the back of the plate. An example of a fixed jack plate is shown here behind me. Now, with the advent of structured wiring and the tough requirements of Category 5 modular jack plates and their associated connectors, they've become much more common than fixed jack plates. Now, these modular plates have simple, usually square molded openings into which they're snapped a variety of connector modules. The advantage of this modular approach is that the connector style terminations and even color are independent from the mounting plate. Now, as the figure shows behind me, the modular jack plate and connectors are listed or shown. Now, the plates are available to hold from 1 to 6 connector modules, so you can mix and match connector options. This means that you can decide to mix 6 and 8 position jacks on the same plate and in any order. Some of the modular systems even have modules for coax and fiber. You can have a phone jack, LAN jack, cable TV jack, and other fiber optic jack on the same plate. Alternatively, you could have phone and LAN connections for two workstations, two workstation positions, all on the same jack plate. Now, while the standards make no requirement for multiple module outlets, they certainly do not prohibit them. And just be careful to include a larger outlet box behind a plate where several connectors may be. You will need a space to coil up all that cable, and the connector module includes the modular connector jack and a terminal mechanism for connecting the cable. The termination is accomplished by several types of IDC connectors, as we have described earlier and will be describing again later on. Now, the construction of the connector termination module generally produces much lower noise and crosstalk than with the conventional fixed jack plates. And for this reason, these jacks are preferred for LAN wiring, even in a Cat3 installation. They also are much easier and quicker to terminate than conventional screw terminals. Now notice we did not say that they were less expensive. Another variety of jack plate is a two-piece modular jack assembly. These assemblies are unique in that they separate the wire termination function completely from the connector function. A typical two-piece assembly will include a backplate module that the wire terminator snaps into after the cable is terminated. The terminator module is essentially a special type of connector that mates with a printed circuit board edge contact area. This arrangement is commonly called an edge connector. The back module then mounts into the outlet box with the normal mounting screws. To finish the assembly, one or more connector modules, each with a PC board edge contact, plug into the terminator module at the rear of the back module. A faceplate is then attached to secure the connector modules in place, and this type of assembly has a unique feature that the front connectors may be changed without re-terminating the cable. So for example, you could change from a single 8-position connector to a dual 8-position one, or change to a 6-position or even a coax module. Of course, fiber connectors are not out because it is cable that is terminated, not the fiber. The figure behind me shows an example of a two-piece modular jack assembly. The modular jacks are often referred to as RJ45 jacks. This is not really the correct moniker, although it is very commonly used. And because all modern LAN wiring uses the 8-pin or 8-position 8-conductor modular plug-in jack, we will call these conductors 8-pin modular or just modular. For a more complete discussion, you can see the box RJ45, what's in the name, in Chapter 9. So let's talk about the termination types. There are two basic types of wire termination that are used with modular jacks for twisted pair wire. These are the screw terminal and the insulation displacement connector, or IDC. Now, the screw termination is the original type that was used with telephone systems. It is still found on some LAN wiring installations, but is not recommended for Cat 4 or 5 operation, and is certainly not for Cat 5e or 6. As a matter of fact, you will probably never see screw terminal connectors certified above a Cat 3, if they are certified at all. Now, you certainly do get a better connection from the viewpoint of a LAN transmission with the other type of termination. For that reason, many installers do not recommend screw terminals for any LAN work. Of course, you do not need to rush around and pull out all your old screw terminal plates that might be in your current network. Just remember that they cannot perform above Cat 3, and that old installations may have space-wired station cable that is untwisted or crossed before it even gets to the screw terminals. Nevertheless, there's still a right and a wrong way to terminate wire on a screw terminal. Proper wire termination for screw terminals is illustrated here behind me. Now, the screw terminal consists of a screw, 2 washers, and a plastic post on the jack plate. The jack's connector wires are normally terminated in an open-end spade lug that is positioned between the plastic post and the lower of the 2 washers. To terminate the station cable, the screw is first loosened. Each station wire insulation should be stripped back about 3/8 of an inch, and the bare copper portion then wrapped around the 2 washers, or between the 2 washers around the post. The wire may be preformed before it is placed into position. The screw is tightened moderately with an electrical contact is made in the sandwich made by the washers in the plastic post. The proper direction for the wrap is clockwise around the screw, and it must be between the 2 washers. The reason we have a clockwise wrap is because when we are tightening up the screw, it would actually cause the wire to wrap tighter. Whereas if we went counterclockwise when we're tightening our screw, turning the nuts down into a clockwise position, it would cause the wire to unwrap. That is the main reason for that. No insulation should be between the washers, and the wire should not wrap back across itself to avoid breaking the wire when the screw is tightened. Some installers strip an inch or more and then wrap the wire around the screw with no overlap. The excess wire should be trimmed after the screw is tightened. It is also a good idea for LAN circuits to try to maintain as much of the pair twist as possible up to the point of termination. Now, some authorities recommend trying to limit the untwist of Cat3 cable to no more than 1.5 to 2 inches. The other type of wire termination is the IDC contact. This contact avoids stripping the insulation manually by cutting through the insulation during the termination process. The wires cut to length, inserted into the contact area, and then snapped into place either by a special tool or by snapping a plastic cap onto the IDC contact. Either action causes a small area of insulation to be pierced and an electrical connection to be made with the underlying contact. There are 3 common types of IDC contact mechanisms: the 66 type, and the 110 type, and the snap-in type. Other proprietary mechanisms include the BICs and the chrome types. Another type of IDC jack contact field is fashioned from a shortened version of the traditional 66 type punch-down block. In this jack type, the wires of the modular connector are connected to positions on the block into which the wires from the station cable are then punched. The amount of untwisted wire from the block to the connector is usually too great for this type of jack to be certified above Category 4, if indeed it is certified at all. Another type of IDC jack contact incorporates the newer 110 type punch-down strip as shown here behind me. Now, the 110 strip may be separate from the modular connector and connected by wires as with the 66 type jacks, or it may be an integral part of the connector module. If discrete wires connect the strip, the same untwisted wire problem exists as with the 66 blocks, and the certification above Cat 3 or 4 is then rare. However, if the block is incorporated into the connector module, the combination can be certified to Cat 5e, and the Home 100 strip has the advantage that it can be terminated with conventional punch-down tools, and its connectivity and longevity parameters are well established. On the other hand, the strip is often wider than the connector module and that is attached to, which limits placement of a mounting plate on a mounting place. Variations of the scheme use the BICs and the chrome blocks, both described in the next chapter, Chapter 7, in place of the 110 block. An alternative to these 2 other IDC connectors is what we are calling the snap-in connector for jack, or snap-in connector for a lack of a better name. As you can see behind me here in the figure 6.8, this connector type is made in a number of styles by many manufacturers. And in general, these designs all have the common characteristics of compact construction and toolless termination. The connector contacts mount directly onto a printed circuit board, which also mounts the modular connector. The wires are each cut to size and placed in a channel above the contact edges. A plastic insert is used to push up to 4 individual wires into the jaws of the IDC contacts, where the insulation is pierced and the electrical connection is made between the wires and the contacts. The insert usually snaps into place with a click, which is why we're calling it a snap-in connector. The beauty of the connector style is that it terminates the wires without any tools. Its compact design leaves room on the connector housing for color codes to match the wire colors. Pin numbers may also be printed on the housing to help the installer. So, non-modular jacks for Cat 7. For some time it's been realized and documented that the old reliable RJ45 style of 8-pin modular plug and jack and the crossed over wiring pattern are the biggest single contributors for the limitation of copper link performance. Old reliable causes crosstalk, return loss problems, shielding issues, EMI, and is generally a pain to assemble. Data networking and with its structured cabling have moved into the radio frequency domain, and the modular plug is a terrible RF connector. With the advent of Cat7 performance standards ranging from 600 to 1200 megahertz, the old RJ45 just won't do the job anymore. Frankly, it is a connector whose time is up. So new non-modular connectors, for lack of a better name, have been developed that are much better to maintain impedance matching and shielding in a very high-speed data link. These connectors support the new Cat7 cables with the individually screened balanced pairs and avoid all of the sins of the RJ45 while maintaining a similar profile for snap-in jacks and snap-lock connections. An example of a high-performance Cat7 non-modular connector is shown here behind me. Now, standard jack pinouts need to be discussed. The standard pin connections for a variety of modular jack styles are shown here. Now, modular jacks are used for many different purposes, of which LAN wiring is only one. The 560AC standard describes two different wiring patterns for wiring the 8-pin modular jack. The two patterns are called 568A and 568B, and they're shown here. Now, the two patterns differ only in placements of two pairs, of pairs 2 and 3 of the traditional 4-pair order. This order is defined as pair 1, the blue pair, and pair 3, the orange pair. Okay, the green in the 4-pair and the brown. The 568A pattern places 2 of the 3 pins and 2 on pins 3 and 6, and the jack, the pair 3 on pins 1 and 2. So basically, what we're taking here is we're switching the green and the orange pairs. Okay. Now the 568B pattern, okay, covered that. The A pattern is actually unique to the TIA standard, but is now the recommended pattern. The B pattern is traditional via Lucent 258A pattern specified in their premise distribution system. Ironically, the A pattern better follows the progression of wiring patterns from the 2-pair pattern for 6-pin modular jacks that is used for many telephone sets, the RJ11 and 12 style jack. There has been considerate controversy to which pattern is the proper one to use. Depending upon whom you ask and where you ask, you can get some strong opinions on either side of the question. The TIA standard, however, is quite clear. The pin pair assignment shall be T568A. Optionally, T568B may be used, but only if necessary to accommodate certain 8-pin cabling systems. These certain systems are the ones that already use the optional pattern for the most part. If you do not need to connect an existing system cable patch that uses 568B, you should use the recommended A pattern. So what difference does it make which pattern that you use, A or B? Electrically, it makes no difference as long as exactly the same pattern is used on both ends. So let's say that again. The two patterns are electrically equivalent as long as both ends of the cable are wired with the same pattern. As has been said, the electrons don't know the wire color. This means that as long as pin 1 and pin 2 on one on the end of the link connect to pin 1 and pin 2 on the other end, and the same is true for pins 3 through 6, and then you can use either pattern. Both the outlet and telecommunications room terminations, punch down block, or a patch of a horizontal cable should be wired with the same pattern. Technically, you can use either pattern. However, some patches or fan-out cables, equipment connectors, and adapters are pre-wired with the 568B pattern, and you must match that pattern at the other end of the cable if you want it to work. You can, however, mix patterns from one cable run to the next within the same link. For example, a patch cord could be wired with either pattern without regard to how the horizontal cable is terminated. Common wiring pattern problem can occur in the horizontal cross-connect. If you terminate the horizontal cable into a punch block first, then cross-connect to a patch, you should be sure that the patch wiring matches that of the corresponding walled outlet, and that you have preserved the pair order during punch down and cross-connect. And we're going to cover that in Chapter 8 when we talk more about patch panels. The official stance of the TIA is that the A pattern is preferred. The statement certainly applies to new installations, since it will be problematic to switch the pattern in an older installation. You could also justifiably choose the B pattern if Avaya or Lucent or AT&T components are used, since that is their standard offering. Now, there's a great debate over which pattern is used the most. The truth is in the hearing. The customary pattern varies widely, depending upon whom you ask and what part of the country or the world that you live in. Personally, I've always gone with the 568B. However, it seems that the A pattern originally was not used as much because it was different from the pattern that had historically been required for telephone use. Now that most manufacturers offer both, you are free to follow the TIA's preference or your own. So what happens if you use one pattern on one end of a cable and a cable run and another on the other end? Most LAN network connections will fail, and telephone connections that require two pair will also fail. Pairs 2 or 3 are used by almost every device that we connect to an 8-pin modular jack. The TIA wiring patterns are considered universal in that they are applicable to several types of connections because they cover all 8 pins of the modular connector. So for example, the TIA patterns can be used for any of the Ethernet connections, such as 10 base, such as 10, 100 base T. The TX and T4 variations are both handled. As for 100 VG any LAN or 1000 base T4 and 100 and 1000 base TX, since all 4 pairs are specified. In addition, the TIA patterns can support token ring, ArcNet, ISDN, T1, ATM, PMD variations, and of course telephone wiring in its many variations. You can make a very good argument that the TIA 568C wiring system is as close to a universal wiring system as we will ever get. Of course, there will always be situations that do not fit this standard model, but more and more equipment is being designed to take advantage of its characteristics. If you choose to diverge from the standard to implement some of the 2-pair technologies, for example, you may be left out in the cold in a very short time. The only practical way to increase data rates on unshielded twisted pair wiring beyond the current 1000 meg data rate is to use additional pair in a multiplexing or encoding scheme. Now this means that you can go to 1000 meg data rate without having to replace installed Cat5e cable links, which are nominally rated to 100 megahertz. However, these technologies need all 4 pair. You cannot very well use 4 pair if you decide to wire just 2, just to save a little money in the short term. It is therefore strongly recommended that any new installation adhere very close to the TIA standards, including the number of pair to each outlet. It is very important to fully understand the categories of operation of the various modular jacks. The TIA and 568C standard contains strict performance requirements for the outlet connectors that are used for Cat3, 5e, 6, and AC6 operation. Requirements differ somewhat by category, although Cat4 and 5 parameters are often the same, and thus Cat4 has now been completely dropped. Although categories 1 and 2 do exist, they are not the subject of the standards because they really are not appropriate for any type of LAN cabling. Components as well as cables should be marked as certified for a particular category of use. Thus, a connector that is intended for Cat5e, you should be marked as Cat5e. However, you may have occasion to need to determine the appropriate use for an unmarked jack. Now, while it may not be possible to categorize an unmarked jack without some uncertainty, there are some guidelines that can help out. If you can identify the jack assembly style, you should be able to determine its probable category of rating. The jack styles and their appropriate categories for use are shown here. Now, of course, any jack that is rated for a higher category than the intended use can be substituted. For example, it is perfectly acceptable to use a Cat6 or Cat5e jack for a Cat5e installation. However, you could possibly upgrade the entire wiring system for very little more cost. The IDC jacks are so easy to use, they are often used even when their higher category of operation is not required. Now, some modular jacks have an extra slot on the side to supposedly limit connections to cable plugs with a matching slot. These side key jacks are largely useless because they easily accommodate a non-keyed plug. The original intent was to protect delicate digital equipment from the higher voltages that can sometimes be present on telephone circuits. For example, the common open circuit voltage for a telephone line in the United States is 48 DC, and the ring voltage can approach up to 90 volts AC, both at low current. However, modern data circuits are fairly immune to these voltages, and the fact that the key jacks are easily defeated has led to their disuse. An alternate style of key jack is the MMJ style that was used by Digital Equipment Corporation, which we talked about in Chapter 3. This jack has primarily been used for the connection of an RS-232 or RS-422 low-speed devices, and is rarely found in other uses. It is not appropriate for standards compliant LAN wiring. Fiber optic outlet jacks. The fiber optic technology has become so important that we've devoted an entire chapter to it when we get to Chapter 11. The outlet jacks for fiber optic connections have several unique requirements. The fiber optic outlet must allow the station cable fibers to be terminated and connected into a jack plate. In addition, the design of the jack plate must allow the easy attachment of an optical jumper to the workstation equipment. A special passive coupling device called an adapter is used to connect the two fiber optic cables at the outlet jack. Unlike the termination of metallic conductors, the traditional termination of an optical fiber can be a delicate and time-consuming process, although the time may be reduced by using some more expensive quick termination connectors. The fiber must be stripped of its protective coverings, including the binder. It must then be precisely cleaved before being inserted into the mechanical coupling, that is loosely called the optical connector. Some fiber connectors require the use of an epoxy or a glue to secure the fiber, and may use a crimp or clamp in an arrangement, in addition or in lieu of the glue. Finally, the connectorized fiber end must be carefully polished to a smooth surface so that the light entering or exiting the fiber is not bent off the axis. The polishing step is not required for quick termination connectors, however. In order for light to couple properly between the connectors, the internal fibers must be carefully aligned and placed virtually in contact by the coupling device. In fiber optics, this coupling device is called an adapter rather than a connector because it does not actually terminate any fibers. It mounts in the fiber optic outlet plate much as a coax bulkhead barrel adapter does in coax systems. The fiber adapter provides a keyed location where the termination station fiber connects on the back side of the outlet plate. The plate is then mounted in the fiber optic outlet box. The fiber optic user cord is connected to the section of the adapter that is on the front side of the outlet plate. Because of the nature of the fiber optic transmission, two fibers and connectors are generally required for each LAN connection, one for transmit and one for receive. Keying these two connections on differentiating them by color is used to orient the transmit and receive fibers. Now there are several types of fiber optic connectors. We'll mention three of these that are often used in LAN wiring. The first and one of the oldest is the Optical Sma Connector, which is shown here behind me. Now this connector is quite similar to the miniature screw on the SMA to the miniature. Screw-on SMA connector used for RF connections on small diameter coax cables. The fiber is contained in a metal or ceramic ferrule and actually comes through to the very tip of the ferrule. The SMA connector allows very precise alignment of the fiber, but has a disadvantage being awkward to use. To connect the SMA, the ferrule must be aligned with the mating connector, and then the outer threaded retaining sleeve must be screwed down to hold the fiber in place. The 905 type connector has a straight 3 mm ferrule. The 906 type has a step-down ferrule that allows two ferrules to be connected by a coupler with a plastic sleeve to align them. The SMA connectors are not designed to be easily paired together to support the standard dual fiber interface. You must mate each fiber connector one at a time. Also, there's no easy way to key this connector so the transmit and receive fibers do not get interchanged. Now, although this connector was once the most common fiber optic connector for routine LAN connections, it is not in a wide use today. Another popular fiber connector is the ST connector, which is shown here behind me. Now, the design of this connector has a bayonet-style outer sleeve that allows the connector to be quickly inserted into its mate and secured with a quick quarter turn. The connector looks somewhat like a miniature Bnc connector. The ST connector had begun to supplant the SMA connector in most equipment and chassis connections. However, it had the same single connector problems that the SMA did. The connections must be made one at a time, and there is no practical way to bind two fiber connections into one unit. In addition, you must orient a tab and a slot on the male and female connectors. Push against the spring mechanism and then turn the locking ferrule to complete the connection. This is a frustrating experience at best. A newer connector called the SC, it allows quick connections, good fiber alignment, and multi-fiber coupling so that two may be combined into a duplex connector for transmit and receive. The SC connector is an unusual looking square-tipped fiber optic connector that is slightly cone-shaped at the tip, as you can see here behind me. Now, the SC is a push-on, pull-off connector that uses spring retention to hold the connector in place when mated, thus avoiding the maddening contortions necessary for the ST. The square design and push-pull coupling mechanism make the connector usable in high-density applications. The SC connector may be coupled in duplex sets with a coupling receptacle or duplex clip. In a key duplex set, the SC connector easily implements a form of polarity matching with coupling adapters in fiber optic outlets or patch panels. This connector was adopted by the TIA as the officially recommended fiber optic connector in the 568-A, although the -B and C revision accommodate other newer connectors as well. The connector is called the 568SC connector in the TIA 568 standard. Now, if we look at small form factor connectors, or SFFs, the largest types of fiber optic connectors are generally called small form factor connectors. Now, these connectors answer the most common objection to the SC style, namely the SC connector cannot accommodate a two-fiber or duplex connection in the space of a single modular RJ style jack. In addition, the design of these SFF connectors allows two fibers to be terminated at once in a single plug or jack module, simplifies the installation and use of duplex fiber connection, and helps minimize polarity mistakes that come with improperly arranged fiber connectors of other types. The SFF connectors were first authorized as part of a general deregulation of fiber connectors in the -B revision, which is continued in the TIA 568, specifically the 568C.3 Optical Fiber Cabling Component Standard. It allows the use of any connector that meets general performance and requirements for fiber alignment, loss, stability under physical loads. The SFF modular style connectors are not required, nor are they prohibited in making this policy decision. The TIA declared its intention to foster innovation and let the market decide which connector style to use. Actually, the rush to non-SCRJ style modular connectors has already begun. So problematic was the original SC implementation. The new standard simply allowed this to continue while specifying some very strict performance ground rules. A collection of the more popular SFF types are shown here behind me. Now there are other outlet jack types. The IBM cabling system jacks, a few other outlet jacks also deserve mention. The first is the IBM Data Connector. The Data Connector shown here behind me is a genderless connector designed so that any connector mates with any other. It's rather a large square-nosed connector with a rectangular body. The Data Connector is designed to be used with shielded twisted pair STP cable, although it can be also used with other connectors. The Data Connector was specified in 568-A as a standard connector for use with the STP-A cable. The use of STP with data connectors was previously specified by an EIA interim standard, the Omnibus specification. The 568-A standard detailed the data connector and its use with the STP-A shielded cable. The data connector's complete electrical and mechanical specifications are contained in the first edition of the IEC 8078 rectangular connectors for frequencies. 4 signal contacts and earthing contacts for cable screen. Now, although this connector specification states that the connectors are for 3 megahertz and below, the TIA has extended their characteristics to 300 megahertz. The color codes for the horizontal 150 ohm STP-A cables are by pair colors. Pair 1, red and green. Pair 2, orange and black. This color code corresponds to the markings for the IDC contacts within the data connector and makes the cable conductors very easy to match with their proper contact. The data connector outlet is a version of the standard data connector that is mounted in a cover plate. Cover plate is attached to a standard outlet box, and the station A cable is then terminated directly into the outlet connector. Versions of data connector faceplates are available that contain both data connector and one or more modular jacks. The data connector and STP-A cabling system is a robust system that offers certification up to 300 megahertz, 3 times the current maximum frequency specification of standard UTV systems. Coax jacks are another type of outlet jack. The Bnc Coax Jack is commonly encountered in 10-base 2 Ethernet cabling systems. This cabling system calls for the thin net segment to be run from one workstation position to the next, and so on, until you reach the end of the segment at each workstation. The 2 cable sections are joined together by a Bnc-T, and the center position of the T is connected to the workstation network adapter. The workstation essentially taps the coax line to become a part of the network. The method generally does not allow an extra stub or coax from the tap to the workstation. Both cable sections must be extended all the way to the T at the workstation adapter. Each fixed 10-base-2 coax outlet then needs 2 coax connectors, 1 for each cable section leading to the workstation. The customary outlet has 2 separate female Bnc connectors on the faceplate, each connected to one of the 2 cable sections at the rear of the faceplate. There are 2 methods to connect the cable sections to the rear of the faceplate. One method connects bulkhead-mounted female connectors directly to each cable end. Each connector is inserted through a D-keyed hole in the faceplate and screwed secured with a thin washer and nut. The alternative method places 2 bulkhead mount barrel connector adapters in the holes of the faceplate. The coax cable ends in the wall are terminated with male Bnc connectors, which are then connected to the backside of the bulkhead adapters from the front. The faceplates look the same regardless of the method you use to connect the ends. From the dual coax outlet connection to the workstation, made with 2 coax jumper cables with 2 Bnc male connectors at each end. At the workstation, the T is connected to the network adapter and the 2 cables connected to the arm to the T. If the workstation is at the end of the coax segment, only 1 cable is used and a 50 ohm terminator is placed on the other T position. If there's no workstation in place, a short coax jumper cable is used to connect the 2 bulkheads connectors on the outlet's faceplate in order to complete the cable circuit to the next workstation. If the workstation position would have been at the end of a coax segment, a single terminator may be used instead. 10-base-2 system requires end-to-end connectivity and dual-ended termination of the coax segment for proper operation. Any disconnected cables or terminators may cause the entire cable segment to cease function. Next, we need to talk about marking the outlets. Outlet jacks should be clearly identified on the faceplate. The identification should include a cable number and jack number, as well as an indication of whether the jack supports data such as LAN connection or telephone. Some jack inserts and faceplates are marked to indicate data or phone. Telephone extension numbers generally should not be marked on the plate, since many phone systems allow the number to be assigned to any physical outlet. The same applies for data jacks that correspond to a particular port number on a LAN hub or other network connection. Needless counts, however, as you must be able to read the cable number later. Outlet jacks are often color coordinated with the room decor, which is fine as long as the standard NE/MA electrical colors are chosen. Non-standard colors may cause a clash with other electrical outlet plates and may be difficult to obtain. If the electrical plates have already been selected, you should try to match those colors. Modular outlet jacks offer a variety of colors for their modular inserts. In theory, the color markings allow one to easily differentiate between, say, voice and data jacks. However, there are really no universal standards for these colors. What may seem to be logical color choice to you could be the opposite of what someone else might choose. You might simply want to leave all the colors in the same neutral color as the faceplate and differentiate the jack's functions with the plate markings. Alternatively, you may choose to leave the telephone connector neutral and use a different color for the LAN jack. So if we talk about workmanship, the subject of workmanship is particularly important with regard to jack termination. The higher categories of wiring have strict guidelines for the amount of untwist that may be present at any point of termination. When a pair of wires is untwisted, even slightly, it can cause a greater disruption to the high bandwidth signal transmission than almost any other non-continuity defect. Furthermore, there are several points of unavoidable untwist in any cable. And the effects of untwist are somewhat additive. You should carefully inspect at least a sampling of cable terminations to make sure that they are done properly. As the figure shows behind me, there's a sample of cable link with one improperly untwisted connector. You can see that there's a very large cable anomaly at approximately 72 feet from the tester. This test link was made up with an intentional excess untwist of 3/4 of an inch at one of the connectors of the 1-foot patch cord. When you compare the size of this anomaly to other connectors which are properly made, you can clearly see the reason we emphasize good workmanship. Patch cords are easy to inspect visually, but your wall outlet jack wiring is hidden in the wall. Be sure that the person who installs your wiring is properly trained to do these connections well, and test each horizontal cable run with a cable scanner. Another issue that affects station outlets is the amount of excess cable that is left at the outlet. Standard practice is to leave no more than 18 inches of extra cable length in wiring in the outlet. This distance is measured from the wall opening to the jack before it is installed. Excess cable should be trimmed before the outlet is terminated. You should leave a reasonable length of extra cable to simplify the initial termination and any subsequent inspections or re-terminations of a cable run. Now, that concludes this chapter. I know it was another long one, but move on to the online assessments, and then I'll see you back here. Well, I'll see you in lab, where we're going to start cabling our room, and then I'll see you back here again for chapter 7 and 8, which will be combined for the next set. See ya.